Hey, what's up, students? Let's do the broken bear claw. I just throw this one out by hand because I didn't want to waste paper printing out a brand new question. So here we go. Okay, we got to take a scientific notation and power it to a 3. Take another one and power it to the -3. And then we got to take a big old decimal times a big old decimal. Technically a very, very small decimal times a very, very small decimal. So here we go. Okay, let's see here. We have a 1.78 times 10 to the 7. So the first thing I would do is I would sprinkle in my 3. So 3 is going to stick to the 7, and the 3 is going to stick to the 1.78. So like a frying pan rule, okay? So what I'm actually going to simplify is I'm going to simplify 1.78 cubed times 10 to the 3 times 7 is a 21. So now I got to make sure my decimal doesn't move here. So let's see what we got here. 1.78 to the third power is, I'm lucky, it's going to be a 5.6 if I round to the third place, which I'm supposed to. It says include 3 significant figures. 5.64. So I'd round the 3 up to a 4. So my answer would be 5.64 times 10 to the 21. Okay, same move. Here we go. -3 times u. Sorry, not times u. Well, actually, yeah, I was right. Times u, but then it would stick to the 5.91. So I got to solve or simplify a 5.91 to the -3 times a 10 to a -24. Okay, now don't write it because the decimal could move, and I got a funny feeling it will. So here we go. 5.91 to the -3rd power is, it's a 0.0048. Third decimal is going to be a 4. Okay, so the rule is with scientific notation, remember you got to move it past the first number that isn't a 0. So it's 1, 2, 3. So it's going to be a 4.84. But if I move the decimal to the right, that means I got to stack more for my exponent. So if I move 3 this way, I have to take away 3 more. So it's actually going to be a times 10 to the -27. Okay, so it's going to be a 4.84 times 10 to the -27. Okay, so remember the decimal, it's kind of weird. So if you move the decimal to the proper location, moving it to the right, you actually take away from the exponent, but as you move the decimal this way, you add to the exponent. So scientific notation is weird. Now I don't know if I want to show you this, I think you can try to do the whole thing at once in your calculator, but you be very careful here. Let's try 5.91 times 10 to the power of 8. Okay, and then you got to go over, no, I don't want that. There we go, I want that, there we go. And then if I take that whole thing to a -3, -3, please. Let's see here. How'd I do? Enter, please. There we go. 4.84 times 10 to the -27. Hey, look at that. I did it okay. Good job. But yeah, make sure you can do it by hand, but you can always double check with your calculator. Speaking of doing it by hand or helping yourself out with a calculator, just for a nice little reference, it wouldn't be bad if you had some decent scientific notation skills. So here we go. 1, 2, 3, 4, 5, 6. This would be 1.23 times 10 to the -6 times 1, 2, 3, 4, 5, 6, 7, 8, 9. 3.15 times 10 to the -9. All right, so big kids multiply, little kids add. So let's do a 1.23 times a 3.15. I don't think that's going to get much bigger than that. 1.23 times a 3.15 is going to be a 3.87, I would say. Now, careful, stop. Just look at the 4. Here's a mistake that some people make. They look at the 5, and they're like, oh, the 5 will round that up to a 5, and that will round that up to an 8. No, stop right there. Okay, look at the next decimal. So it's going to be a 3.87. 3.87. Big kids multiply, little kids add. That's going to be a -15, I believe. There we go. All right, let me try to do this on my calculator. See if my calculator can do this for me. Here we go. So we have a 0.1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros. 1, 2, 3 times 0.1, 2, 3, 4, 5, 6, 7, 8, 3, 1, 5. All right, look at that. 3.87 times 10 to the negative 15. We got them. All right, cool. So that is the broken bear claw. Powering scientific notation. Follow your frying pan rules. Follow your big kids, little kids rules, and everything will be just fine.